Hello and welcome. Today we are going to learn about how to use Google Colab as a tool for running Python commands for data mining and machine learning. Here in this lecture we will introduce you with Python programming for data science, demonstration of simple commands. We will use input-output commands. We will use how to load different packages and libraries, and we will demonstrate the libraries like Numpy and Pandas. We will also discuss how to read and write data to the files. First of all, we will create a coding cell here using insert a code cell. In this cell, we will write a simple Python code to import some package or library. We can use import command, and we will type the library name numpy, and we will use it as np. We will create a object or a variable name np, and we will load the numpy library using this simple code. We will run this code using control enter. Now you can see a green tick demonstrates that this code has run, and there is nothing wrong with this code. After that, we will create another coding cell using alt enter, and in the very next cell we will create an array, create a list, and that list will then be converted into numpy array, and we will use a Python code, and we will demonstrate how we can create a list using Python code, and how we can convert this list into numpy array. Here the simple code is, first of all we will write a comment here that we are creating a list, and we will write the code x. We will take a variable x, and we will create a list with different number. For example, we can type in 1, 7, any sort of number you can take, or you can type 3, 4, 0, and we can write for demo purpose, we can write just simply -5, and we have written almost 6 elements in it. We have created a list. In the next line we will use Python code to convert this list, convert it to this list to an array. We will write the code. We can write that code as like this: y is equal to, we will use numpy dot array, and we will pass the variable x, that the name of the variable of the list, which has the members of the list. Then we will print and check its shape, that what type of this data holds, or what type of dimension it has. We will check the dimension using different commands, like we will type here print, and we type check the type of the y, what type of variable it is. and we will run this command, control enter. You can see it will create a list, and you can see the print, everything has been executed, and there is no error in it. And we can see that it is showing in a print that class numpy dot n dimensional array and array, and it's been displayed. Now we will create another cell, alt enter, using alt enter, and we will check the shape of this array. We will type print, or we will type y dot shape. Y dot shape, it will display the shape of this array. I will run this code, control enter. It should, and it is showing the, it has 6 elements in it. Using numpy, we can specify defined range of values to create a new array. Now we will define a range using another cell. We will create another cell, alt enter, and we will define the range, and we will pass the 5. We will give the range of 5 number that will create range. If we run this code using control enter, let's see what it displays. It's saying range 0 to 5. It has displayed the range. Now we can see we can write a command like this. Create another cell, alt enter, and here in this cell we will type print. We will type print, and in that print function we will pass np dot array, and then we will pass np dot array the range of the list that we want, 4 to 8. It will generate a range of numbers from 4 to 8. Let's execute this code and see what does it displays. We will use control enter command to run this. Now you can see it should print the number from 4 to 7. Now you can see it has printed the range. We will create another cell, alt enter, and in that cell we will print the elements from 2 to 3 spaced by 0.2 units. We will create a range with a difference of 0.2, and it will be between between the two numbers 2 and 3. We can use the print command same as above, print, and in print braces we will type in np dot arrange. We will use arrange function. It will be from 2 to 3 with the difference of 0.2, and we will run this code. It must sure we will comment the purpose for this is print elements from 2 to 3, that this will print elements from 2 to 3 spaced by 0 spaced by 0.2 units. This is a comment only, that the hash sign you have written any text. These are just comments, and these will not be the part of the coding section or code. these lines will not execute. These are just for demonstration and helping text that will demonstrate that what is the purpose of the code that we have used here. Now we will run this code using command control enter. Sorry, it's showing some error. We will check that what type of mistake we have done. Here we have spelling mistake in arrange. We will type arrange spellings proper. Arrange we have to type arrange, and now we will run it again. We will execute now. Yeah, it has created the list and with the difference of 0.2 between 2 and 3. Similarly, you can create any type of with any type of ranges with difference of any linear scale you want to create. For example, we will create another. For example, we want to create a line space. We will create another cell, and in that cell we will use the function line space print. In print we will type np dot line space, and in that line space we will type the range 2 to 3 and 5, and we will run this code using control enter. If there is some problem with the code as well, we have to type only linear space, then we will run it, control enter. Sorry, it was not line space, it will be a linear space. Now you can see that it has executed the code. It will return numbers spaced evenly on a linear scale. Both endpoints are included. Now we will create another cell, and in that cell we will use a log space. We will type the print command, and we will use the function of the numpy dot log space. It will display the log space between the given range that we will specify here. It will be 2, 3, 5, and now we will run it, and let's see what type of result does it show. It will show the log space between the number range we have demonstrated here. We will run the command control enter, and it will display the result 100, 177. This will show the log space within the range. Now you can see the code has been executed, and we have seen the log space. Further, we will create another cell, alt enter, and here we will type we can create or reshape an array to a new specified shape keeping its contents. Here we will create an array. For example, a variable a is equal to np dot array, and in that array we will type the members of the array like this. We will start a brass here, and we will type in the array members 1, 2, and then first row we have created, and we will create the other row. It will be like this, 2 comma, as we do in the matrices, 3 comma 4, and we will then use the print command to print this array. Let's run this code. Control enter. Now you can see here an array has been created. The output is like this: 1, 2, and 3, where 2 rows are created. We can reshape this array using another code. We can create another cell, control enter, and here in this code here we will type the a is equal to np dot reshape, reshape, and we will run this code. Reshape array, we will pass the a comma 4. It will reshape it like in a single row, and we will run this code and see how it gets printed. Print, and we will run this code. We use control enter. Now we will run this code using control enter, and you will see that this array will be reshaped. You must be showing results down here. You can see it has been reshaped. The array has been reshaped into a single row. Before this it was in 2 rows, displaying data in 2 rows. Now it is showing data in a single row. Similarly, we can use a command to append elements to an array. We can use append function of the numpy array. We will create another cell, alt enter, using alt enter, and we will type the command a is equal to np dot append, and we will use the same array that we had already in append function. We will pass the same array, and we will add another element to it. For example, we will add 5 to it, and let's run this code and see how it prints print the array, what type of member it has. Now we will run it, control enter, and you can see that on member 5 has been added to this array. Similarly, we can create a matrix from an array, like object or from a string of a data. A matrix is a 2D array. We can use it to create an identity matrix using NumPy. It is a square array with ones on the main diagonal. We can use a command like this. We will create another cell, and in that command we will demonstrate how we can create an identity array. Here we will type a is equal to np dot identity, and we will pass the value 3 to it, and it must generate a matrix. We will run this, control enter. We will first of all print its shape. Print shape is a dot shape, and we will and contents are, we will display the contents as well. Contents are, we will print here a. It will display the content of the a as well. We will run this code, control enter. It will display the 3 shape and 3 rows and 3 columns of this identity matrix, and it's also showing its contents that and then 3 cross 3 matrix has, how it is displayed. We can find dot product of two arrays using NumPy. We can, first of all we will create two arrays and then we will get the dot product. For this, the dot product, we can demonstrate the dot product like this. We will create another cell. We will create a new matrix using C is equal to np dot three comma 4, and here we will print it, print C, and then we will check the shape of this C. We will print C dot shape, and we will run this command and we will see how the data is being displayed. Now we will create here a is equal to, we will create array and we will get the dot product. A is equal to, we will create an matrix. We will create first row 1 comma 0 like this, and then another row 0 comma 1, It's a 2D array. We will create another 2D array in B. It will be like this. We will type here 4, comma 1. It will be the first row of that second 2D array, and we will create another array, another row. Now you can see 2D. We have created two 2D arrays, and we will now get the dot product of these 2D arrays. For this, we will use np dot a comma b. We have passed the 2D arrays to the dot function, and now we will print C, that what type of data it holds, and then we will type the shape of the C. Print C dot shape. Now let's run this code using Control Enter and see the results. It has wrong spelling here. Print. Sorry. We run it again. Now it is working well. Now you can see here you can see the output here. We have the two arrays, and we got the result. We had members of A and B, and then we got the result C by having dot product. The final resultant matrix is 2 cross 2 matrix, and its shape has been displayed 2 comma 2. This is how matrices are created in, and how you can do the dot product. We can get the dot product results from there. Here we will simply use this code for the demonstration of 2D array dot product. Here we had two arrays, and finally we have shape here, 2 rows and 2 columns, shape of the resultant array. We will compute the arithmetic sum, means, and standard deviation using Numpy. For example, we can create an array, and we can get the sum. We will use the sum function to get the sum of that array. Here we can see A is equal to np dot array, and we will create an array 1 comma 2. This is first row, and we will create 4. We will create another row 3 comma 4, and next we will print np dot sum. We will pass A to it. It must print the sum. We have not specified any access for the sum, just we have provided the A array to it. Now we will run this command and see what happens. It's not working. There must be some error here. Spellings are right. Print np dot sum. Okay. we have to specify the x is equal to sum a comma x is equal to 0. Here we have missed the brackets for the matrix. Now we will run this. It will work now. We will first of all execute without access, print it without access, and then with access. Let's run this code. Now you can see it has printed the sum of a, and now it has printed the sum with access. If we see that it has added in with access is equal to 0, it will add 1 to 3, it will create 4 here, and it will add 2 to 4, it will create 6 here. And if we type the access is equal to 1, then let's see, we will copy this. We will demonstrate here the difference. What type of results are when the access are modified. Here we will type access is equal to 1, and we will run this code and see what type of change has occurred. Now you can see access is equal to 0, it has added row member columns, column to column. And now if we add we will see if we change the access, it will add rows to row. Row members will be added in the change of access version. 1 and 2 are added 3, and 3 and 4 are added equal to 7. These row members are added, and these row members are added in access when access are 1. And now you can, when access are 0, you can see this 1 has been added to this 3, and this 2 has been added to this 4. This was all about the arrays, and we can use the mean function as well. We can get the mean. We will demonstrate it using another code, another cell. We will create another cell, alt enter, and we will demonstrate here how we can use the same thing for the mean as well. Instead of sum, we will use mean function. It will create the mean of the, we will type mean instead of sum, and you will get the results accordingly. Mean, and here we will type again the mean, and we will run this code. Let's see what type of result it shows. Here you can see it has created the mean according to the axis. Firstly without access, and then in the second line we use 0 access, and in the third line we use the 1 access as we did in the sum. Same is the case with the standard deviation. We can create another cell, and in that cell we can use the same code for the standard deviations. We can use the standard deviation instead of, we will copy the code and we will type std instead of mean, and it will show the standard deviation according to the mentioned axis. Now we will run this cell and see what happens. Here you can see it has provided the standard deviations of the members as we have continued with. Here we have all demonstrated about different function, how we can use NumPy to get different results from different. We have demonstrated NumPy for the use of creating lists and converting them into the arrays, and we have demonstrated the NumPys as arrays, and we have used matrix calculation here. We have calculated the dot products of the matrices. We have converted the list into the arrays using NumPy. We have used those arrays to demonstrate different functions of sum, mean, and standard deviations. This is all about the NumPy functions, and in the next video we will demonstrate further details of NumPys, how we can use or implement data science using the NumPy, and how useful NumPy is for the data science. We will create another video and we will discuss in detail the features of the NumPy, and further we will talk about file input and output. We will demonstrate reading, updating, and writing files, and we will create different files, like we will transfer data to the Excel file, and we will read data from the Excel files, and we will perform different functions on that data. We will clean that data, and we will apply different machine learning techniques on them, and we will predict different results on the basis of the data provided to us. Okay, goodbye.